Previous lecture we were discussing subspaces, subspaces of a vector space. So let's review very briefly what are subspaces. Subspace, we discussed that let V be any vector space, let V be any vector space. Okay. Then any subset of non-empty subset of V is called a vector, is a subspace of V if W is itself a vector space under the same operations of addition and scalar multiplication. So this was technically the definition of a subspace. But we also discussed that if the elements of the W set, which is a subset of the bigger set of V, if the elements of W satisfy two properties, which were clear law under addition, okay, clear law with respect to addition or under addition, we call it. And what is this law? For all maybe U1, U2, or W1, W2 belongs to W set, implies W1 plus W2 belongs to W. So the first definition, the second, first property, and the second property was the clear law under scalar multiplication. Okay. Clear law under scalar multiplication. So what was it? It was for all the scalars C, for example, belongs to R, and for all elements W belongs to W. This implies C times W belongs to W. C times W belongs to W. So these were the two properties. If the elements of the subset satisfy these two properties, then we say that W is a subspace of V. Remember that the operations of addition and scalar multiplication should be same for these two sets. Trivial subspaces are, you can say that, trivial subspaces of any vector space. If these two subspaces will always exist for any vector space. W, which contains only the identity element of a vector space, and W is itself C, V. Okay. W could be V as well. And any set W which contains only the identity element of the vector space V, this is also this is a subspace of V. And if W is W, W is equal to V, also a subspace of V. So these are two trivial subspaces of any vector space. These two spaces always, subspaces always exist. Okay. Now we were talking about
जो हमने यहाँ पे उल्टा A आपने डाला, I mean flipped upside down, इसका मतलब ये है for all.
For all, for every, okay? For every pair of elements in W, or for all, or you can say for any two elements. Okay. It can mean. So these are two trivial subspaces. For example, last time we were discussing subspaces of matrices. We discussed a lot of subspaces of Euclidean vector spaces as well. We were discussing vector subspaces of matrices. For example, if we have Mn is what? Is a set of all matrices. Okay. Matrices of order n cross n. Means these are square matrices. Okay. And we define a set W, which is a subset of this Mn. And what kind of this set is? A set of all matrices with trace equal to 0. What does it mean with trace? Set of all matrices. Just wait for a second. Okay, can you listen me?
Yes.
Set of matrices with trace equal to 0. Trace is what? Trace of any matrix is what? Trace of A. If A is a square matrix of order n, then trace is what? The sum of its diagonal entries. Sum of diagonal entries. Diagonal entries of A. If A is a square matrix of order n cross n of this kind, A11, A12, so on, A1n, and A21, A22, so on, A2n, and so on, AN1, AN2, so on, AN. Then trace of A is what? Trace of A is A11 plus A22 plus so on plus AN. Okay, we can write it in short form as well. I from 1 to n, AII. Okay, this is how we define the trace of any square matrix. I hope you understand. If you have any question, you can ask. Now, in order to prove whether this W set is a subspace of this Mn, what we do, we have to prove two properties. The first one is clear law under addition. For that, what we need two matrices for all A, B belongs to W. What we have to prove, this implies A plus B belongs to W. Okay. Now, when this A plus B belongs to W, anyone?
So when it satisfies the two properties?
No, this is the first property. We are talking about first property. Clear law under addition. We have to prove that this elements of W satisfy the clear law under addition. Okay.
So their sum belongs to the rational numbers?
No. What kind of elements are there in the W?
Real numbers. Real numbers.
I told you that you were not listening to me. What kind of?
We should give us
Yes.
trace is equal to 0.
Yes.
Oh.
All the matrices which are in W, they have trace equal to 0. Okay. Now, if we choose two elements from the W, we know that their traces, the trace of A is 0 and trace of B is 0. Okay. Now, in order to prove that whether this A plus B belongs to W or not, what we have to prove? We have to prove that trace of A plus B is 0. Then we can say that A plus B belongs to W. You have to look at the properties of the elements of that set. Okay. Now, we have to prove that trace of A plus B is equal to, we know that trace of A plus B is equal to, in fact, trace of A plus trace of B. This is the property of trace. Okay, remember, I told you, yes, I told you many properties of transpose of a matrix, inverse of a matrix, and I asked you to read more properties regarding trace and transpose and inverses. So this is one of the property of trace. This is called linearity property of trace. Now, if this trace of A plus B is equal to trace of A plus trace of B, then we know that trace of A is already 0 plus trace of AB is already 0. It means that trace of A plus B is 0. What does this mean? A plus B belongs to W. Because its trace is equal to 0. All the elements in W have trace 0. So now we can say that this clear property under addition holds for the elements of W. And the next thing, the second property, we have to prove the clear property and the scalar multiplication. So the second property is basically now what? For all the scalars, maybe k belongs to R and A belongs to W. What we have to prove? K times A belongs to W. Now, when this K times A belongs to W, when we can prove that trace of K times A is equal to 0. Okay? We know that trace of K times A is equal to K times trace of A. And we know that trace of A is equal to 0, so K times 0 is equal to 0. It means trace of K times A is again 0. What does it mean? It means that K times, this implies K times A belongs to W. Okay. So this holds the clear property under scalar multiplication. So when these two properties hold in any subset of a vector space, then we call W is itself a vector space, and it is a subspace of the bigger set, which is vector space. I hope you got it. If you have any question, you can ask.
Sir, will this have a zero vector?
Zero vector, what? Can you repeat your question?
Will this example have a zero vector?
Zero vector is 0 null matrix, 0, 0, 0, 0, and so on. N by n null matrix. Its trace is already 0 because the sum of diagonal zeros is again 0. So that is basically what the identity element of this subset W. That is there. The identity element or null matrix is there in this W. Any other question? I hope you get it. If you have any confusion, you can
Sir, I don't really understand why the closure laws change to, from A plus B belongs to W to, trace of A plus B belongs to W. I can't make the connection between them. And similarly, for the scalar law for scalar multiplication, that trace of K times A belongs to W.
again, you need to concentrate, or you need to basically critically think about the sets and their elements. Okay? What kind of elements are there in W? W contains elements of M, N, such that trace of A is 0. Okay? W is this kind of a set. Now, what is the condition on the elements of W? These are elements, these are some. Basically, W is a subset of Mn. Mn is a bigger set, larger set. It contains all the scalar matrices. Okay, but you are choosing only those matrices of order n from Mn who have trace equal to 0. Okay, how many matrices there would be? There would be infinite many.
Yes.
Mn contains infinite many elements, infinite many matrices of order n. ठीक है, उसमें से हमने कुछ element choose कर लिए, which are again infinite many elements, whose trace is only 0. Okay. Now, do you agree this W is subset of Mn?
Yes.
Okay. Now, we have to prove the clear law. Clear law is what? Under addition. For any 2A, B belongs to W, what we have to prove? A plus B belongs to W. ये प्रूफ करना ना हमने.
जी सर.
अच्छा, A और B W को बिलोंग करते हैं, उन दोनों की ट्रेस 0 होगी, नो डाउट, बिकॉज को W को बिलोंग करते हैं. अब हमने ये प्रूफ करना है कि A plus B belongs to W. तो A plus B कब W को बिलोंग करेगा? जब वो W के एलिमेंट्स की प्रॉपर्टी को सेटिस्फाई करेगा.
सही सही. I understand now. जी जी.
So that's why we need to prove that trace of this A plus B is 0, then A plus B will belong to this set W.
I understand.
Got it? Okay. Similarly, in the second case.
सर
So
ये
you have-
यूजुअली जब हम वेक्टर के साथ पहले करते थे तो हमारे पास W की जगह रियल नंबर्स होते थे, राइट?
W की जगह रियल नंबर्स नहीं, वो वेक्टर्स होते थे यूक्लिडियन स्पेस के.
हाँ जी.
Those call them vectors. Now,
Right.
it depends on the elements of a space. How do we write them? अगर यूक्लिडियन स्पेस में से एलिमेंट्स होंगे तो उनको वेक्टर्स x बार, y बार, स्मॉल अल्फाबेट लेटर्स के साथ हम डिनोट करते हैं. Lekin when you have matrices, set of matrices, then these are basically denoted by capital letters. Okay?
Right.
And they are matrices. In fact, we call them as a vector in general. Because general vector spaces mein elements, we say that elements of a vector space are vectors. Okay? So these are kind of vectors, but we don't say them vectors because they are matrices. But intuitively, you can think of these elements as vectors. I hope you get it.
Sorry.
Okay, then now one more example of subspace, and then we shall move to the next topic. Polynomial. This Pn of maybe x. Pn, yeah, in general P cap. Pn is the set of all polynomials of degree less than or equal to n. And how can you define polynomial of degree n? Pn of x. It is an x power n plus an minus 1 x power n minus 1 plus so on plus a1x plus a naught. Okay. This is a polynomial of degree less than or equal to n, depending on the coefficients, where an minus 1 and so on, a2, a1, a naught, they are scalars. Scalars here are basically real numbers. So this is a polynomial of degree less than or equal to n. How do we define addition of polynomials and scalar multiplication of polynomials? If we define another polynomial, which is qn of x, and it is nothing but bn x power n plus so on plus b1x 1 plus b naught. Okay. And how do we add them pn of x plus qn of x? We add basically the coefficients of like powers of x. So this is an plus bn times xn plus an minus 1 plus bn minus 1 times x power n minus 1 plus so on plus a1 plus b1 x1 plus a naught plus b naught. So this is basically standard addition of two polynomials of degree as an equal to n. And how do we, this is standard addition. How do we define the scalar multiplication for the polynomials? We multiply a scalar with a polynomial, and in fact, we multiply the scalar with every coefficient of the polynomial. So this is an xn plus so on plus k times a1 x1 plus k times a1. So this is what? This is the standard scalar multiplication of polynomials. We can prove that this set is a vector space by using these two operations of addition and scalar multiplication. Now, let me define, I hope you can prove it. If you are unable to prove it, you can ask the TA in the tutorial to help you to prove all the 10 properties for this set. For example, if you say that P2, if you say P2 of x, and this is what kind of a set? It is a set of all polynomials of degree less than or equal to 2, such that this P2 is what? P2 is a kind of polynomial of degree, कह सकते हैं. P2 is a polynomial of degree less than or equal to 2.
सर आपने कहा था कि अगर ये दो प्रॉपर्टी सेटिस्फाई हो जाती हैं तो बाकी सारी हो जाती हैं, ऐसे ही है ना? So we don't need to
No.
prove all of them.
This you have to prove a vector space. When someone asks you to prove whether the set is a vector space or not, then you have to prove all the 10 listed properties. Okay? If I ask you to prove whether if this is a bigger set V, now I'm going to define W. Okay? W is what? W is a set which contains P2 of X such that P2 of X is a polynomial of degree equal to 2. Okay. Now, would this set W be a subset of this V or not? क्योंकि bigger set W में, sorry, V में polynomials of degree less than or equal to 2 हैं, और जो W है उसमें polynomials of degree 2 only है, उसमें less than 2 नहीं हो सकता. Exactly second order polynomials हैं, second degree polynomials. Now, would this set be a subspace of this V? You have to prove now two properties, clear property. Okay. Now, let's try the first property. First property is what? For all P2 of X and Q2 of X belongs to W. P2 of X को हम define कर देते हैं A2X square plus A1X plus A0. And Q2 of X को हम define कर देते हैं B2X square plus B1X plus B0. Now, can we say that P2 of X plus Q2 of X is again a polynomial of degree 2? Can we say that?
No, sir.
Why?
You can.
Sir, because B can be negative A and that would make it a polynomial of degree 0.
B2 can be a negative of A2. That would make a polynomial of degree 1. Okay.
No, sorry, yes, degree 1.
This need not to be, this need not be a polynomial of degree equal to 2. Okay? What does it mean? P2 of X plus Q2 of X. It doesn't belong to W. If it does not belong to W, then clear property under addition is not satisfied. It means this W is not a subspace of V.
Sir, can you explain this again, please?
What's your confusion?
About this property.
What we have to prove here, in order to prove the clear property in addition, we choose two polynomials for W, and then we say that sum of these two polynomials of degree 2 belongs to W. And when this sum will belongs to W, when this sum is again a polynomial of degree 2, exactly equal to 2. Okay? But whenever we add them, we can see that this B, there is no condition on A2 and B2. Okay? यहाँ पे condition, यहाँ पे क्या हो सकती है? Condition could be A2 is not equal to 0 in this case. A2 is not equal to 0. Similarly, Q2 आप define करें B2x square plus B1x plus B0. And you have to put a condition B2 is not equal to 0. Because if A2 or B2, they are 0, then this P2 and Q2 will no longer be a polynomial of degree 2. Okay? We can put these two conditions. But there is no restriction here that we cannot choose B2 is equal to negative of A2. Okay? If we choose here negative A2, then the sum of these two polynomials will be what? Will be a polynomial of degree 1. Or you can say that the sum of these two polynomials is not a polynomial of degree 2. It can be a polynomial of degree 1. It can be a polynomial of degree 0 as well. So we say that this P2 of x plus Q2 of x, it does not belong to W. So the clear property under addition does not hold. So the W is not a subspace of V. I hope you get it.
इस सारे को इंटरनलाइज करने में थोड़ी मुश्किलात पेश आ रही है, इसका क्या हल हो?
क्या प्रॉब्लम है?
सर इंटरनलाइज नहीं हो रहा ये टॉपिक, मतलब कि वो इंट्यूटिवनेस नहीं आ रही है इसकी कॉन्सेप्ट की.
देखिए, you have to keep in mind the properties of the set. अगर आपके पास सेट में पॉलिनोमियल्स ऑफ डिग्री 2 हैं, जैसे पहले हमने मैट्रिसेस की एग्जांपल की. मैट्रिसेस में प्रॉपर्टीज क्या थी एलिमेंट्स की? W में n क्रॉस n मैट्रिसेस से जिनकी ट्रेस 0 थी. ठीक है, तो अब दो एलिमेंट्स लेके हमने ये प्रूफ करना है कि सम भी उसी सेट को बिलोंग करता है. तो हमने क्या प्रूफ करना है? उस सम की ट्रेस 0 प्रूफ करनी है, तब वो उस सेट को बिलोंग करेगा. अब यहाँ पे W सेट क्या है? इसमें पॉलिनोमियल ऑफ डिग्री एग्जैक्टली इक्वल टू 2 है. ठीक है, हमने क्लियर लॉ अंडर एडिशन प्रूफ करना है ना, तो हमने दो पॉलिनोमियल्स लेने हैं और प्रूफ करना है कि उन दोनों का सम भी एक सेकंड डिग्री पॉलिनोमियल है ताकि वो बिलोंग करे W को. ठीक है, तो यहाँ पे फिर हमने we try to prove that if we choose two polynomials of degree exactly equal to 2, then their sum is also sum belongs to W. And when the sum belongs to W, when the sum is a polynomial of degree exactly equal to 2. Okay, तब ये W को belong करेगा. So you have to keep the properties and limitations of the elements of that set W. Okay.
Right.
Even if we don't have any bigger set W, we have a W set. We have a W set which contains all the polynomials of degree equal to 2. And you have to prove it a vector space. तो फिर आपने 10 की 10 प्रॉपर्टीज प्रूव करनी है. 10 की 10 प्रॉपर्टी प्रूव करने से पहले सबसे पहले आपने पहली प्रॉपर्टी प्रूव करनी है. पहली प्रॉपर्टी ही वायलेट होगी, तो ये वेक्टर स्पेस भी नहीं. This set cannot be a vector space as well.
सर अगर पहली वायलेट होगी तो बाकी करने की जरूरत नहीं ना.
अभी आप कह सकते हैं कि ये वेक्टर स्पेस नहीं है. अगर मैं ये आपसे पूछ लूं कि कौन कौन सी प्रॉपर्टी वैलिड होती है, तो फिर आपको सारी चेक करनी पड़ेगी. ठीक है,
ओके सर, ओके.
Now we are moving towards linear systems as linear combinations. Linear systems as combinations. Let's discuss this thing with the help of an example. Consider this linear system x1 plus x2 plus 2x3 is equal to 9, and 2x1 plus 4x2 minus 3x3 is equal to 1, and 3x1 plus 6x2 negative 5x3 is equal to 0. Yes. Previously, we usually write any linear system into a matrix notation. Matrix notation में क्या होगा? Ax is equal to B, where A is what? Is the coefficient matrix. Where A is what? Is the coefficient matrix 1, 1, 2, sorry, 2, 4, -3, 3, 6, -5 times x1, x2, x3 is equal to 9, 1, 0. I hope you remember this form, matrix notation of a linear system. This is matrix form of a linear system. Now we are going to write this linear system into a different form. Can I write now this linear system into this form? 1, 2, 3 times x1 plus 1, 4, 6 times x2 plus 2, -3, -5 times x3 is equal to 9, 1, 0. Can I write this linear system in this form? What I have done here, मैंने ये जो पहला कॉलम है इसका, इसमें से x को कॉमन ले लिया है, बाकी इसके जो कोफिशिएंट्स है, I have written them in vector form. 1, 2, 3 times x1, the second coefficients of x2 in the second column here, 1, 4, 6, 1, 4, 6, and then coefficients of x3 here in this system. 2, -3, -5. 2, -3, -5. x3 times x3 is equal to the right hand side vector.
सर एक कंफ्यूजन है अभी
जी जी
सर जो x1 के एलिमेंट्स हैं वो तो फर्स्ट रो वाले हैं या फर्स्ट कॉलम वाले हैं?
x1 के एलिमेंट्स तो ये x1 का कोफिशिएंट यहाँ पे है, x का 1 का यहाँ पे, x1 का यहाँ पे, ये तो x2 का कोफिशिएंट है यहाँ पे, ठीक है?
जी 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 सॉरी वो आई वाज बीइंग कंफ्यूज्ड बाय हाउ वी राइट द
ठीक है? So now we are going to write it differently. Okay? पहले आपके पास एक मैट्रिक्स फॉर्म में लिखते थे हम, अब हम उसको वेक्टर फॉर्म में लिख रहे हैं। जी 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 बेटा।
सर आपने ये नहीं कहा था कि जब हम जैसे x1 कॉमन ले रहे हैं तो वो क्यूब में होता है, अगर वो तीनों में मेंशन है, वो कब होगा?
This is do you know what is scalar multiplication with a vector? How do we multiply a vector with a scalar? अगर आपके पास यहाँ पे कोई वेक्टर है x1, x2, so on, x1 में ना करें, कंफ्यूज करेगा आपको। यहाँ पे है आपके पास c1, c2, so on, cn। अगर आप इसको किसी k स्केलर से मल्टीप्लाई करेंगे तो ये क्या होगा? स्केलर जो है वो सबसे मल्टीप्लाई होगा, k times c1, k times c2, so on, k times cn। This is how we multiply vectors with scalars। ठीक है? अब यहाँ पे आपके पास x1 is constant. This is a scalar in fact, and we are putting the coefficient of x1 in a vector form. Now, when we multiply x1 here with this vector, what do we get? x1, 2x1, and then 3x1. यहाँ पे ये वेक्टर आ गया। अब दो वेक्टर्स को कैसे ऐड करते हैं हम? दो वेक्टर्स को हम या तीन वेक्टर्स को कैसे ऐड करते हैं? पहला कंपोनेंट पहले में ऐड होगा, फिर पहला कंपोनेंट इसमें ऐड होगा, दूसरा कंपोनेंट, दूसरा कंपोनेंट, दूसरा कंपोनेंट, तीसरा कंपोनेंट, तीसरा, तीसरा, ये तीनों ऐड होंगे। So you will definitely get again this linear system by equating or by taking the sum of these three vectors and putting that vector equal to this right hand side vector. You'll get the same linear system. If you have any confusion, you can ask me. I can give you an example. I can explain it more by taking the sum of these three vectors. जी
प्लीज एक्सप्लेन कर दें, थोड़ा सा ये वाला समझ नहीं है वैसे बात।
ठीक है, यहाँ पे जब आप मल्टीप्लाई करोगे x1 को तो आपके पास क्या आएगा? 1x1, 2x1, 3x1। ठीक है, यहाँ पे आएगा। दूसरे में क्या आएगा? 1x2, 4x2, 6x2 प्लस यहाँ पे क्या आएगा? 2x3 minus 3x3 and negative x3। यह आएगा इक्वल टू 9, 1, 0। अब आप इन तीनों वेक्टर्स को ऐड करोगे, क्या आएगा?
1x1 plus 1x2 plus 2x3
plus 2x3। ठीक है, दूसरे में क्या आएगा? 2x1 plus 4x2 minus 3x3। Similarly, तीसरा आप लिख लेंगे, जो कि equal to what? 9, 1, 0। Now, when two vectors are equal when the corresponding components are equal। Okay?
जी जी।
अब इनको equate करेंगे, what do you get? You get the same linear system।
Sahi.
Okay? So this is how we write it in this form. Now, here we call this vector a V vector, maybe. And this is V1. This is V2 vector. Okay? And this is your V3 vector. Okay? And the right-hand side vector, you can call it V vector. Now, how can we write this linear system ultimately? V1 vector x1 plus V2 vector x2 plus V3 vector x3 equal to V vector. So now a non-homogeneous linear system can be written in this form, which is entirely different from this matrix form. Okay? I hope you get it. Now, we say that if we can write any linear system in this form, we say that before writing this, now tell me, this is a non-homogeneous linear system. And we solve this non-homogeneous linear system for what? What is unknown here? X1, X2, and X3, they are unknown. If we can solve this linear system and find the values of X1, X2, and X3, such that if we multiply those values with V1, V2, and V3, and we solve this left-hand side, we get the vector B. Okay. Then we say that B is a linear combination. Of the vectors V1, V2, and V3. Geometrically, what does this thing show us? पहले आप इसको mathematically देख लें, then we'll see it geometrically. Any vector B is called a linear combination of some other vectors V1, V2, V3 if we can write B in this form. Okay. We say that B is a linear combination of the vectors V1, V2, V3 if we can write B in this form. This is called the linear combination of B in terms of the vectors V1, V2, V3. Okay. Where x1, x2, and x3 are some unknown scalars. What is the general definition of linear combination? I hope you get it. If you have any question, you can ask. Now, I'm going to write the general definition of linear combination. Let W belongs to V. V is some vector space. And V1, V2, so on, Vn. Be any other set of vectors in V. Be any set of vectors in V. All these vectors are, they basically belongs to the same set, V. Okay. Then W is said to be a linear combination of vectors V1, V2, so on, Vn, if V can be written as. V can be written as. Kaise? V is equal to some scalar k1 into v vector 1, some other scalar k2, v2 plus so on, plus kn vn. Okay. Sorry, not b, it's w. Not it's w. Okay. So if we have a vector w which belongs to b, v, and some other vectors which are also the elements of v, then we say that w is a linear combination of the vectors this v1, v2, so on, vn, if w can be written as. Now, what is this basically? In this linear combination, w is known. W is known, and these vectors v1, v2, so on, vn, these are also known vectors. Okay. What is unknown? Unknown is k1, k2, and kn. Okay. These are unknown scalars. Unknown scalars. In fact, what is this thing? This is a non-homogeneous linear system. This is a non-homogeneous linear system. And we can solve this non-homogeneous linear system in order to find the values of these unknown scalars, k1, k2, so on, kn. As we have seen here that in this non-homogeneous linear system, unknown scalars are what? x1, x2, and x3. These are unknown scalars. And v1, v2, v3, and b, they are known vectors. So a linear combination is basically, for any linear system, or in general, any linear combination is basically a non-homogeneous linear system. And after solving this non-homogeneous linear system, we can find the value of k1, k2, and kn. Then we say that W is a linear combination of these vectors v1, v2, so on, vn. Let's have an example of this thing. Meanwhile, you can ask me any question if you have any confusion. किसी का mic on है शायद? Turn off your mics. Yeah. Example. Find the scalars C1, C2, C3 such that the vector W belonging to a cube is a linear combination of the vectors v1, v2, and v3. v1, v2, v3 is 1, minus 1, 0. v2 is 3, 2, 1, and v3 is 0, 1, 4. And W is given as W is -1, 1, 19. Now we have to check whether we can write W is a linear combination, W can be written as a linear combination of the vectors v1, v2, v3 or not. For that, what we do, we write W, in fact, we write W as W is equal to some scalar C1 V1 plus C2 V2 plus C3 V3. Okay. Now what is W? W is -1 119 plus C1 is a scalar, we have to find it. V1 is 1 -1 0 plus C2, what is V2? It is 3 2 1 plus C3 is 0 1 4. Okay. Now what is this? This is basically a non-homogeneous linear system, which is what? It is C1 plus 3 C2 plus 0 is equal to -1. And the first component के साथ C1, C2 और C3 मल्टीप्लाई करेंगे, आपके पास ये पहली इक्वेशन आ जाएगी, उसको इक्वेट करेंगे -1. सेकंड इक्वेशन क्या आएगी? -C1 plus 2C2 plus C3 is equal to 1. और तीसरी क्या आएगी? यहाँ पे 0 है, plus C2 and plus 4C3 is equal to 90. So you get this non-homogeneous linear system. And the unknown in this non-homogeneous linear system is what? C1, C2, and C3. After solving this non-homogeneous linear system, we can find the values of C1, C2, and C3. And the values of C1, C2, and C3 are, after solving this, we obtain the values of C1 is equal to 2, minus and 5. 2, C2 is -1, and C3 is 5. So we obtain these three values. I hope you can solve this non-homogeneous linear system. Now, if you put these values here in this linear combination, so C1 is what? It is 2, C2 is -1, and C3 is 5. Now, if you solve this side, you must get -1 1 19 is equal to -1 1 19. So it is true. It means W can be written as a linear combination of V1, V2, and V3. I hope you get it. If you have any question, you can.
सर जब भी हम सॉल्व करेंगे लीनियर इक्वेशंस को, तो हम इनको वो एलिमेंट्री रो ऑपरेशन से सॉल्व करेंगे, मैट्रिक्स वाली या नहीं तो सिंपल वाली जो होती है,
जो मर्जी मेथड आप यूज कर लें. यू कैन यूज Gaussian elimination method, Gauss-Jordan elimination method. You can use the method of by inverting the coefficient matrix. Okay, inversion of a matrix coefficient. You can use any method in order to solve that linear non-homogeneous linear system. Now let's come back to the solutions of non-homogeneous linear systems. Now, if someone asks you, check whether we can write B as a linear combination of the vectors V1, V2, and V3. We can write as a linear combination or not. We don't need to find the scalars. Then how can you do it without solving that linear system? Anyone?
Sir, can you repeat your question?
If I ask you, only check whether we can write W as a linear combination of V1, V2, and V3, we can write it or not?
Sir, I think एक सबसे पहले तो वो होना चाहिए ना कि आपका जितने आपके वेक्टर्स होंगे उतने आपके स्केलर्स होने चाहिए.
वो तो ठीक है.
फिर शायद
देखिए, जब आप लीनियर कॉम्बिनेशन में लिखते हो तो ये क्या है? नॉन होमोजेनस लीनियर सिस्टम. अब नॉन होमोजेनस लीनियर सिस्टम को सॉल्व किए बगैर कैन वी चेक कि इसका सॉल्यूशन एग्जिस्ट करता है या नहीं?
सर इसमें डिटरमिनेंट्स का तो कुछ चक्कर नहीं आने वाला.
किसी भी नॉन होमोजेनस लीनियर सिस्टम का यूनिक सॉल्यूशन कब एग्जिस्ट करता है?
When the determinant is 0.
जब तक when the coefficient matrix is invertible. यार आपको कितने दफा बताया है ना?
Yes, sir.
When the coefficient matrix is invertible, and when a matrix is invertible,
When the determinant is
it's-
not 0.
it's not 0. Okay. If I ask you, check whether we can write W as a linear combination of V1, V2, V3 or not. What you have to do, you just have to check the determinant of the coefficient matrix. Coefficient matrix or what? You have to put these vectors in this matrix form, V1, V2, and V3. You make a matrix by using these vectors. These are basically column vectors. So this A will be what? In fact, 1, -1, 0, 3, 2, 1, 0, 1, 4. So this is your coefficient matrix of that non-homogeneous linear system. If this matrix has inverse, if A inverse exists, then what? That non-homogeneous linear system, which is W is equal to C1 V1 plus C2 V2 plus C3 V3. This non-homogeneous linear system must have a unique solution when A inverse exists. A inverse exists, or you can say that determinant of A is non-zero. अगर इस non-homogeneous का unique solution exist करता है, then there exist values of C1, C2, and C3, so that this homogeneous linear system is true when we put the values of C1, C2, and C3. So it means we can write W as a linear combination of the vectors V1, V2, and V3. Is there any other method to check whether we can write B as a linear combination of the vectors V1, V2, V3? और भी बहुत सारे methods हमने पढ़े हुए। एक तो ये A inverse exist करे, ये determinant 0 ना हो, और क्या हो सकता है? Using echelon form, if we say that number of pivot elements in the echelon form of A is equal to the order of A, then we can write B as a linear combination of V1, V2, and V3. Why is it so? Because if number of pivot elements in the echelon form of A is equal to the order of A, then what? Then its inverse exists. ये भी हमने पढ़ा था. So you can have multiple options to check only whether we can write W as a linear combination of V1, V2, and V3 or not. If you want to write it literally, W as a linear combination of V1, V2, and V3, then you have to write it in a form of a non-homogeneous linear system and solve it and find the values of C1, C2, and C3. I hope you get it. If you have any questions, you can ask. Now, what is the linear combination geometrically? Here we have an example of the vectors in R cube. Let me, for simplicity, just to make you understand, let me take the vectors from maybe R2. So this is your R2, R square. We have a vector. Let me use some different color. We have a vector U, and this is V1 and this is V2. These are two vectors. Now, what is a vector scaling? When you multiply a vector by some constant, basically what does happen? It may be extended. Okay? अगर ये V1 यहाँ तक है, so this could be 2 or 3 V1, or for example 2 V1. और इसको अगर हम scale करें, तो this is what? It may be 1 by 2, 3 by 2, 3 by 2 P2. ये scaling होगी वेक्टर्स। अब इन दोनों को अगर हम ऐड करें, तो ऐड करने से क्या होगा? You get this factor, and with this vector, you can make a parallel. Sorry, this parallelogram. Now this is what? This is a vector 2v1 plus 3 by 2 v2. This is a new vector, which is a linear combination of these two vectors, 2v1 and 3 by 2 v2. Linear combination, this is basically the sum of these two vectors. Now, in a linear combination, what you do, in fact, W is equal to C1 v1 plus C2 v2. Okay. W is what? Is a linear combination of v1 and v2. In general, what is a linear combination of two vectors? It is basically the scaling of the vectors plus the addition of those vectors. First, we scale those two vectors and then we add them to get a new vector, which is basically here it is the length of a diagonal, this diagonal vector of this parallelogram. I hope you get it. If you have any.
सर इस concept को please repeat करते हैं.
इस W को हम यहाँ पे क्या लिखेंगे? It is 2v1 plus 3 by 2 v2. So original vectors are v1 and v2, which are in red. Okay. Now, what is the linear combination of these two vectors? It is 2v1 plus 3 by 2 v2. So we are scaling basically v1 by a factor of 2 and v2 by a factor of 3 by 2. We are scaling them, then adding them. So this is your W vector, which is a linear combination of these two vectors, v1 and v2. This is the geometrical interpretation of linear combination of two vectors in R. In R3, it will become a parallelepiped, a 3D kind of parallelogram. तो उसका जो diagonal element होगा, diagonal होगा, वो क्या होगा? Linear combination of three vectors. I hope you get it. If you have any question, you can ask me. Now, what if that linear combination, that linear system is homogeneous? What if? What happens? All these concepts are basically related to linear systems. Now, if 0 vector is equal to C1 V1 plus C2 V2 in R2, for example. Yeah, R3. This left hand side is 0. Now W is nothing but a 0. Now what is this now? This is a linear system, but it is a homogeneous linear system. Okay. It is a homogeneous linear system. Then we have two cases. Case 1, homogeneous linear system के solutions की कितनी possibilities हैं? 2 possibilities हैं. कौन सी हैं?
Sir, unique solution या infinite solutions.
If this homogeneous linear system has trivial solution या आप unique solution कह सकते हैं. Unique solution of a homogeneous linear system is always a trivial solution, which is a 0 solution. Okay. If this homogeneous linear system has trivial solution, what does it mean? This implies C1 is equal to 0, C2 is equal to 0, and C3 is equal to 0. ये होगा ना? अगर इसका trivial solution है सिर्फ इस homogeneous linear system का, तो C1, C2, C3 तीनों क्या होंगे? 0 होंगे. दूसरा केस क्या है? Case 2. If homogeneous linear system has non-trivial solutions. What does it mean? कि जो आपके C's हैं, C1 will not be 0, C2 will not be 0. आप ये ना कहें, आप ये कहेंगे कि at least one of C1, C2, and C3 is not equal to 0. Anyone? अब अगर आपके पास इस homogeneous linear system का trivial solution है सिर्फ, तो हम क्या कहेंगे कि ये जो vectors हैं, they are linearly independent because they don't have any relation with each other. We cannot write one vector as a linear combination of some other vectors in this set. They are, then we say that the vectors v1, v2, v3 are linearly independent. Okay. They are
Sir, कब कहते हैं?
huh?
When do we say this?
When this homogeneous linear system has only the trivial solution. It means all the constants C1, C2, C3, they are all zeros after solving this homogeneous linear system. Then we say that
Sir, and the determinant will also not be equal to.
huh? Then we say that these vectors
Sir,
V1,
they
V2,
linearly
V3 are-
independent तब भी होंगे.
huh? Linearly independent होंगे अगर ये homogeneous linear system का
Sir, I was saying that they're also going to be linearly in.
आपकी आवाज कट रही है यार. I cannot listen you properly. Can you?
Sir, can you hear me now?
Yes, I can. You can
Sir,
repeat
sorry,
your.
मैंने सारे class की flow disturb कर दी. I was just going to say that they're also linearly independent when the determinant is not equal to 0.
Why?
Because then they have a trivial solution. Then the
Yes.
equation is solvable.
Yes, simply. If you have this homogeneous linear system, you don't need to write this homogeneous linear system. If you want to check whether three vectors v1, v2, v3 are linearly independent or not, you just have to put those vectors in a matrix and check whether the determinant of that matrix is 0 or not. If the determinant is non-zero, we say that they are linearly independent. Why? Because if the determinant of the coefficient matrix of this homogeneous linear system is non-zero, then this homogeneous linear system will have only trivial solution. Okay. So if you want to check whether these three vectors v1 and v2 and v3 they are linearly independent or not, you just put them in a matrix. जैसे कि हमने पहले A में v1, v2, v3 लिखे थे, तीन कॉलम वेक्टर्स में आपके पास 3 by 3 मैट्रिक्स आए. उस मैट्रिक्स का डिटरमिनेंट अगर नॉन जीरो है तो ये linearly independent. दूसरे केस में when if this homogeneous linear system has non-trivial solutions, means C1, C2, C3 किसी एक की या तीनों की non-zero values आ जाती हैं, then we say that these three vectors are linearly dependent, opposite of the independent. Okay. Then we say that then the vectors v1, v2, and v3 are said to be linearly dependent. Okay.
Sir, what does linearly dependent or independent mean?
I told you graphically. Let me draw the graph once again. पहले हम मैथमेटिकली देखते हैं कि लीनियरली डिपेंडेंट का मतलब क्या है. देखिए, अगर आपके पास दो वेक्टर्स हैं R2 में, v1 और v2 है, ठीक है, आप c1 प्लस c2 को लीनियर कॉम्बिनेशन लिखते हैं, इसको 0 के इक्वल पुट करते हैं. अब आपके पास ये एक होमोजेनियस लीनियर सिस्टम है. अगर c1 0 आ गया, c2 0 आ गया, इट मींस दे आर लीनियरली इंडिपेंडेंट. अब दूसरा केस ये है कि c1 की वैल्यू 2 आ गई, c2 की वैल्यू मे बी 5 आ गई. Then how can we write this if we put this c1 here, 2v1 plus 5v2 is equal to 0. What does it mean? It means v2 is equal to negative 2 by 5 of V1. What does it mean? V2 is dependent on V1. We can obtain V2 by multiplying a scalar with V1. It means V2 is dependent on V1. They are not linearly independent. They depend on each other. What does it mean graphically or geometrically? Geometrically, if you have two vectors, this one and another one, this is V1 and this is V2. Okay, they are linearly independent. But if I say that this is your V1 and this is your V2, are they linearly independent? No, V2 can be obtained by multiplying V1 by a scalar. They depend on each other. One vector can be obtained from other vector. They depend on each other. Where we cannot obtain V2 from V1 or V1 from V2. They are linearly independent. It means they make a parallelogram. Okay? और इसका जो determinant होगा ना इन दोनों vectors का, if we make a matrix out of these two vectors, determinant इसका क्या होगा? Non-zero होगा. Means ये area होगा उस parallelogram का. If the two vectors are linearly independent. If they depend on each other, then we cannot make that parallelogram out of these two vectors. In this case, determinant of the matrix, which is formed by putting these two vectors in that matrix, this determinant must be 0. So, अभी हमने पहले कहा था कि अगर वेक्टर्स को हम कोएफिशिएंट उसको A मैट्रिक्स में डाल दें और मैट्रिक्स का डिटरमिनेंट अगर नॉन जीरो है तो वो क्या होंगे? लीनियरली इंडिपेंडेंट होंगे. ठीक है, लीनियरली इंडिपेंडेंट होंगे मींस वी कैन मेक अ पैरेललोग्राम आउट ऑफ दोस टू वेक्टर्स. अगर लीनियरली डिपेंडेंट अगर पैरेललोग्राम बनेगी तो उसका डिटरमिनेंट उसका एरिया होगा. अगर एरिया होगा तो डिटरमिनेंट नॉन जीरो होगा. अगर ये दोनों एक दूसरे पे डिपेंड कर रहे हैं तो वी कैन मेक पैरेललोग्राम, और पैरेललोग्राम अगर नहीं बनती तो उसका एरिया नहीं होगा. अगर एरिया नहीं होगा तो डिटरमिनेंट डेफिनेटली जीरो होगा. I hope you get it. If you have any question, you can ask me. So, in case of linearly dependent vectors, we can write one vector as a linear combination of other vector. अगर आप इसको थोड़ा सा जनरलाइज करें हम, तो ये क्या है? अगर यहाँ पे एक और वेक्टर होता C3B3 equal to 0 वेक्टर. अब अगर आपके पास C1 की वैल्यू मे बी 2 है, C2 की वैल्यू -9 है, C3 की वैल्यू -3, whatever. And if we put these values here, what does it mean? 2V1 minus 9V2 minus 3V3 equal to 0. What does it mean? They are not linearly independent. We cannot make a parallelepiped by using these three vectors. अगर parallelepiped नहीं बनती तो फिर parallelepiped का वॉल्यूम नहीं आएगा. वॉल्यूम क्या होगा वो मैं बताता हूँ. अगर ये linearly dependent है तो any one vector can be written as a linear combination of other two vectors. So we keep this V1 here and we took them on the other side, V2 by 2 and plus 3 by 2 V3. Now what is this? This is what? This is nothing but C1 V2 plus C ना करें आप, तो पहले ऊपर C के और हमने यहाँ पे कोई और कांस्टेंट कर दी, K1 V2 और K2 V3. Here you have V1. अब आपने देखें यहाँ पे क्या है? If they are linearly dependent, then any of these three vectors can be written as a linear combination of other two vectors. Means one vector can be obtained with the help of other two vectors. These three vectors are not independent. They depend on each other. That's why we call them linearly dependent vectors. They depend on each other. one vector can be obtained by multiplying some scalars to other vectors and then adding them. They are not independent. Whereas if all these C1, C2, and C3, they are 0, then we cannot obtain one vector as a combination of the other two vectors. In that case, we say that those three vectors are linearly independent. We can make a parallel, जैसे यहाँ पे दो vectors से हमने parallelogram बनाई थी, अगर आप 3D में काम कर रहे हैं तो इसका 3D वर्जन क्या होगा, parallelopiped होगा, और 2D में इसका determinant क्या होगा, इसका area होगा. 3D में उस जो parallelopiped होगी उसका area नहीं होगा, volume होगा. तो volume होगा जो कि उसका determinant होगा. और determinant किस matrix का find करना है? A matrix which is obtained by putting those vectors in column form here in the matrix. अब इस determinant, इस matrix का determinant क्या होगा? अगर 3D में है तो volume होगा, volume of that parallelepiped. अब अगर आपके पास ये तीनों इंडिपेंडेंट वेक्टर्स नहीं है तो पैरेललोपाइड नहीं बनेगी. वो क्या बनेगी? वो 3D में नहीं बनेगी, वो माइट बी 2D में पैरेललोग्राम बन जाए, लेकिन 2D शेप्स का वॉल्यूम नहीं होता, तो वॉल्यूम क्या हो जाएगा? 0 हो जाएगा. इन दैट केस इसका डिटरमिनेंट जो है वो क्या होगा? वो नॉन जीरो होगा अगर पैरेललोपाइड बनती है. अगर नहीं बनती, लीनियरली डिपेंडेंट है वेक्टर्स, तो इसका डिटरमिनेंट 0 होगा. आई होप यू गेट इट. इफ यू हैव एनी क्वेश्चन यू कैन आस्क मी.
So ये जो हमने केस पढ़ा इसमें लीनियरली डिपेंडेंट है ना? ये वाला C1 B1 जी
डिपेंडेंट
जी तो इनमें डिटरमिनेंट इज 0
होगा. यहाँ पे ये 0.
अगर हम C1, C2, C3 0 कर देंगे फिर तो ये इक्वेशन 0 इज इक्वल टू 0 हो जाएगी ना. उसके सॉल्यूशंस कहाँ से आएंगे?
देखिए ये होमोजेनस लीनियर सिस्टम है ना आपके पास. होमोजेनस लीनियर सिस्टम है, ठीक है. अगर आप इसको सॉल्व करोगे तो ये क्या है? होमोजेनस लीनियर सिस्टम है इस टाइप का, इक्वल टू 0. अगर ए का डिटरमिनेंट नॉन जीरो है, अगर ए का डिटरमिनेंट नॉन जीरो तो इन्वर्टिबल होगा ना. अगर ये इन्वर्टिबल होगा तो आपके पास सॉल्यूशन क्या होगा? सिर्फ 0 होगा. इट मींस यहाँ पे x लिखा है, मैंने c लिखना चाहिए, a into c, और आपके पास c वेक्टर जो होगा 0 होगा. इट मींस ये C1 0 होगा, C2 0 होगा और C3. After solving this homogeneous linear system, we obtain that these constants are 0, not before. ठीक है. तो ये वेक्टर्स क्या होंगे? आपस में लीनियरली इंडिपेंडेंट होंगे. अगर ये 0 नहीं होंगे तो फिर हम एक वेक्टर को किसी दूसरे दो वेक्टर्स की फॉर्म की लीनियर कॉम्बिनेशन की फॉर्म में लिख सकते हैं. Consider this as a W. And this is V1 and V2. Now, this is a linear combination of the two other vectors. Means one vector can be obtained by using two other vectors. I hope you get it. If you have any question, you can ask. कोई भी अगर आपने किसी वेक्टर को लीनियर कॉम्बिनेशन की फॉर्म में लिखना है तो बेसिकली क्या करेंगे? W आपके पास वेक्टर है और एक सेट है वेक्टर्स का. अगर आपने W को एज अ लीनियर कॉम्बिनेशन ऑफ दीज वेक्टर्स लिखना है तो हम क्या करते हैं? We basically write an expression of this form. Which is basically a non-homogeneous linear system. We solve the system and obtain the values of C1, C2, and so on, Cn. If those values exist, then we say that W can be written as a linear combination of these vectors. If this non-homogeneous linear system has a solution, at least one solution, then W can be written as a linear combination of these vectors. Otherwise, if this non-homogeneous linear system does not have a solution, then we say that W cannot be written as a linear combination of the vectors V1, V2, so on, Vn. It is possible कि इस non-homogeneous linear system का solution exist ना करे. It is possible ना? I hope you can. हाँ, ये एक example है यहाँ पे. Example is show that there does not here, do not exist scalars C1, C2, C3 such that C1, V1 को डायरेक्ट हम लिख देते हैं यहाँ पे C1 minus 2 9 6 plus C2 negative 2 2 1 plus C3 1 7 5 is equal to 0 5 4. यहाँ पे उसने वेक्टर्स को horizontal form में लिखा हुआ है. So you can write them in a vector, in a column form as well. So just to save the space, usually in books they write vectors in this form. You can write vectors in the horizontal form as well, row vector kind of thing. But ultimately you can write them in a column vector form first, and then you can obtain a non-homogeneous linear system. You have to solve that non-homogeneous linear system, and you would find that non-homogeneous linear system does not have any solution. If this non-homogeneous linear system does not have any solution, then we say that we cannot write this vector as a linear combination of these three vectors. I hope you can do it.
सर सॉरी आप रिपीट कर सकते हैं? हम नॉन होमोजेनियस लीनियर सिस्टम को सॉल्व करेंगे फिर
तो सॉल्यूशन एग्जिस्ट नहीं करेगा.
अच्छा सही.
ठीक है, सॉल्यूशन एग्जिस्ट नहीं करेगा तो हम क्या कहेंगे कि दिस वेक्टर, दिस इज योर W vector. W vector cannot be written as a linear combination of V1 vector, V2 vector and V3 vector. You got it?
Yes sir.
If you have any question, you can ask me. Otherwise, time is up. I think we should start the next topic in the next lecture. Any question?
Sir, C1, C2, C3 infinite solution है या no solution है?
यहाँ पे if this non-homogeneous linear system has at least one solution, then we can write W as a linear combination of other vectors. अगर solution नहीं exist करेगा, then we cannot write W as a linear combination. At least one solution means एक solution भी हो सकता है और infinite में भी हो सकता है. ठीक है? अगर at least one solution होगा इस non-homogeneous linear system का, then we can write W as a linear combination of these three vectors. Okay. But that linear combination will not be unique. क्योंकि आपके पास infinite many solutions है ना, C1, C2, C3 के. So W can be written as a infinite many times or kinds of linear combination of these vectors V1, V2, V3. अगर unique solution होगा तो W can be uniquely written as a linear combination of V1, V2 and V3. अगर solution exist ही नहीं करेगा, then W cannot be written as a linear combination of V1, V2 and V3. Okay. I hope you get it.
Thank you.